A well-organized project with good project management and structure is key to a successful game production. Without a well-organized project, assets can get lost, animations can be missed, versioning can be difficult, and the project can slow down. In this chapter, we'll look at organizing our Zombie Toys game project here in the Unity editor and explore more of the functionality of the project window. What we have currently in our project window is the default Unity project we created, and then the assets that we downloaded from the asset store. I've got folders in here for animations, audio, fonts, and so forth, and these are our raw assets, ready for a little bit more organization here in our project window. One of the first parts to successful project management is a good naming structure. I'll take a look at some of the models in here. Going into models, and we can see that we have nice names. They're organized alphabetically here in my Assets Models folder, and at the moment they're fairly recognizable. Arc, arches, bat, blocks, and so forth. These are fairly simple because the project is fairly simple. However, it's very likely in a larger game we'll be dealing in thousands of assets, perhaps even millions if there are ones that are created dynamically. Therefore, good naming is essential, and what we may find is that very quickly we'll transition from nice naming to a more complex alphanumeric, one that comes with a legend where each couple of letters, perhaps, means a different thing. Here's an example of a possible longer name, where we're seeing different two-letter combinations and different numbers mean different things. We can't necessarily read this straight out, but what this may mean is that this is an environment model, static as opposed to dynamic, and it's a model, not a texture. This is part A, number 1. So we might have A through Z, or even double A and so on, and then each of those can have a numeric variation. This also denotes that this is version 01, and this way we can keep track of different versions if we're comparing and contrasting. In this case it's an FBX, but this naming convention is fairly flexible and extensible. We might see other things appended, so we can easily sort out in just a list of names things like textures, animations, scripts, models, and so on. In our Unity project then, it's important to have good consistent naming and something that's recognizable and acceptable to everybody on your team. The same goes for the folders in the Assets folder. These folders need to have reasonable, logical names, in this case animation, audio, fonts, and so on. We might do some organization in models, perhaps breaking into characters, environment, and props. Or in scenes, if there are more than one scene, we might see smaller and larger scenes so we can recognize them and call them uniquely if needed. We might also see in the script some organization. For example, here in scripts we've got attacks, enemy, helpers, managers, player, and UI, and each of these folders contains different scripts that do different things. As a general rule in project management then, make sure you stay organized, and every asset should have a name and a place, and should be in its place so it can be indexed easily. Keep in mind then that Zombie Toys is a small game. We're going to have one scene that's one level, and that's the entire game. But it's very likely that we'll have thousands of objects and dozens of scenes, quite possibly in a larger game. And staying organized and allowing for collaboration by multiple people on a project is key to getting that project done on time. In this video, we'll go to the Unity Asset Store and download our content into our Unity project for our Zombie Toys game. In the Unity editor, choose Window and Asset Store from the top menu. The Unity Asset Store allows you to download content directly into your Unity editor. There is both free content available and content you can purchase. In the Asset Store, we'll search for our Zombie Toys game project, typing in the search field at the top, Zombie Toys, and pressing Enter. In the Asset Store window, we can see that the search has found all of our Zombie Toys packages. These are all packages that correspond to the different start states for each chapter. Scroll down and choose the Chapter 1 to 3 Zombie Toys project. Click on the Zombie Toys icon, and the Asset Store will open that package. As a reminder, you should be running Unity 5.3.4 or later, as these assets are made for that release of Unity or a later one. Clicking on the Download button will download your content straight into the Unity editor. For any asset, there are images available of the asset, as well as a preview video and a list of the package contents. These are Unity packages, special files that are encoded from within the Unity editor and published to the asset store. We can see here in our package contents all kinds of different assets that are part of our Zombie Toys game. These range from sound to models, textures, materials, and scripts, and more. Scroll up to the top and click Download. When the license agreement pops up, click Accept to accept the license agreement for our Zombie Toys game. Unity has finished downloading the content, and now we can import it into our Unity editor. Click Import on the Importing Complete Project dialog that's popped up. When you download content from the Asset Store, Unity will open a list of all the contents of that package, and this will allow you to select some, none, or all of the items you wish to import. For now, we'll leave these all checked. You can also click All or None down at the bottom, and then selectively go through and choose Assets. Click Import down in the bottom right of this dialog, and Unity will import those assets into your Unity project. Unity has imported our assets from the Asset Store directly into the Unity project, and we can see them now in the Assets folder in the project window in the lower left corner of the interface. Now we can start building our Zombie Toys game. Remember, at any point, you can create a new Unity project if you'd like, and download a particular chapter's asset package into that Unity project from the Asset Store. Next, we'll look at collaboration and source control for working in a team on a project in Unity. In this video, I'll take a look at importing assets into a Unity project from an offline file. What I've done is to download the Chapters 1 to 3 Zombie Toys package, and I've unzipped the zip file so I have a folder on my desktop containing the assets. I'm going to make a new Unity project and show what it looks like to bring these in. If you already have a Unity project created, the process is the same. I'll create my project here in my documents called Zombie Toys. This is my blank Unity project. Blank because there's almost nothing in it, just the default main camera and directional light. Now there's a number of ways to import assets. You can choose Assets and Import New Asset or Import New Package. What I'm going to do though is drag them in using the Finder or the Windows Explorer. What we can see here is I've browsed into that Certified Developer Courseware Chapters 1 to 3 Zombie Toys folder. And there's audio, fonts, images, models, and scripts, different folders that contain assets. For example, if we look in Models, we can see all the different FBX files we're going to use, plus some other folders for materials and so forth. The neat thing about a Unity project is you can drag a number of assets into your Assets folder in a project, and Unity will recognize that and automatically import them. Here's how I'll do this. I'll select all of these files and press Command or Control C to copy them. I've browsed into my Zombie Toys project and there's the Assets folder, and in here I'll choose Assets and paste them in, Command or Control V. Alternately, you can drag them between Finder or Explorer windows. I've pasted those assets in. What happens then is when I click back on the Unity editor, it will automatically recognize those assets and import them. Unity is recognizing that there's new assets in that Assets folder in the project file, and it's importing in those assets. Unity has finished importing in the assets, and now I can see those same folders here in my Assets folder. Browsing into them, such as models for example, shows me all the different models, imported in appropriately, and ready for further configuring. Remember that the Unity editor will recognize anything that's changed in the Assets folder and automatically import it. So if you're working on assets and want to keep them separate before import, work in a separate directory. For example, I'll work in a separate Maya project when creating my assets, and then when I'm ready, I'll export them out to my Unity project as FBX files. Now that we've imported our assets, we can start building our Zombie Toys game. Remember also that anytime we need, we can choose Window and Asset Store and go to the Asset Store to download content straight into our Unity editor. You may want to browse in here for additional assets, scripts, or plugins to bring into your project to further customize your Zombie Toys game. In this video, we'll look at doing some organization on our Zombie Toys game project. Remember that in previous videos we had created a new Unity project and downloaded these assets from the Asset Store into our project. So whatever organization these assets had is what comes into our Unity project. Right now, we're seeing just the folders that this project came in with. Some folders don't have anything in them. For example, the Animations folder is there and it's blank. In the Assets then, it shows as an open folder. Folders that have objects in them, such as audio, show as closed. To get into any folder, simply double-click. There's all of my different audio files, possibly ready for some further organization. To create a new folder then, simply right-click in the project window and choose Create, and up at the top is Folder. I'll make a folder, for example, called Props. And I'm going to put my model props into it out of my models directory. To move folders around then, simply drag them where you want them to go. I'm going to nest props in models. I'll double click on models or open it up here on the left side in the hierarchy, and there's models and props. In models then, I'll select the different props that go on the floor and pull them into the props folder. I'll pick my arc, hold Shift, and select the blocks. This will select a range of objects. Alternately, you can pick one, hold Control or Command, and select another, adding to that selection. I'll take these 4 models for my props and drag them into the props folder in the hierarchy on the left side of the project. I'll skip over the characters and then grab the doll arm, hold Shift, and click on the hearse. I'll hold Command or Control and deselect the girl, making sure that she doesn't get moved over to the props. I'll take these objects, holding Command or Control and deselecting floor so it doesn't go with it, and I'll pull these into props as well. The doll arm, doll house, drawers, fire truck, and hearse. I'll pull the robot in, leave the sheep alone, and grab the spinning top, stool, and train. I'll come back and grab the clock and pull it into the props folder. Now I have my characters and major environment pieces left in my models folder. Again, I can create folders such as environment and characters and drop these different models in, organizing further within my models folder. Remember to do all of your organization in the project window in Unity. Here's the reason behind this. Unity creates meta files for every asset we pull in, as a way of keeping track of all the different things and where they reside in that project structure. We need to make sure that Unity updates the meta files and libraries to keep track of where different objects are and how they're used in the different scenes. I'll open up my Finder and take a look at what that structure looks like with those hidden files. I browsed into the Assets directory here in my Zombie Toys game project in my documents. What we can see here, because I've enabled them, are all the different meta files that go with each folder or object in my project structure. These are files that Unity creates, and typically they're hidden. If you'd like, you can enable hidden files in either Windows or Mac and show these different files. Typically though, I'll leave them hidden, but I'll know that Unity needs to make them and update them, and these tell Unity where the different pieces are located and where they belong in the project. Back here in Unity then, I'm ready for more organization. I'll take a look through the other directories and see what else there is I can organize into folders. Here in the audio folder, I've got my different attack sounds for each of the attacks we'll be creating later. I've also got some background music and other character sounds. This is an opportunity for more organization. We might want to create folders, for example, for the different attacks and separate those out from the different player sounds and non-player character sounds. Again, I'll right-click and choose Create and Folder. I'll call this new folder in Audio Attacks. And then again, I'll take my different attack sounds, such as WPN Electric Attack, and pull them in. I'll drag them over into Attacks. I'll select the rest of my attacks and pull them in. These are my different weapon attacks, WPN, and continue organizing my audio folder. Even if you're working on a small project, it's important to be organized, and I can't stress this one enough. And the reason is, good habits now in organization will serve you well on larger projects and in larger teams. When you're collaborating with other people, it's important to stay organized so that everybody can find the object or asset they need to be working on and get it into game efficiently. The Unity editor can take in many different files and formats, and it's important to stay as organized as possible, as we've seen. I've already started to organize my different incoming assets into folders here in my Assets folder, segmenting the audio attacks, for example, into an attacks folder. Later I'll create a folder for the different player sounds and the different enemy sounds. In Models, I've placed the prop models in a Props folder. There's already a folder there for materials, and this is created with the incoming models. In Materials, then, we'll see the different materials that are on our objects. These imported in from whatever application they were created in, 3ds Max or Maya, for example. We can see here, when we select, for example, the clock material, that it's a standard shader with specular setup, and the texture maps that were on that object came across. These materials are fairly basic, and they're ready for some adjustment in their properties to really make them shine in the game. However, the textures are in the right place, and this is part of the import process. As a side note, it's important then to preserve that materials folder, and here's why. When we go to the import settings on a particular model, such as an FBX, in this case the clown, and go to the model, what we'll see here is that the materials are checked to import. Additionally, we have some different options for the material naming and material search, and depending on what we choose determines how they come in, where they go, and how they update. In this case, what we'll see is the material naming is by the base texture name, although we can change it to from the model's material, or the model name and material name. We can also see in here a material search. Are we looking recursive up, a local materials folder, which we're in currently, or project-wide? And what this lets us do is configure where we look for an existing material, so that if we import in a new model, we have a choice then to either duplicate the material or use an existing with that same name depending on how we search. So it's important to be aware of where the materials come in with imported assets. In addition to sorting in folders, it's a good idea to assign tags as much as possible. For example, I'll select all of my character models here, holding Command or Control to add to the selection. And with the boy, clown, dog, girl, elephant, sheep, zombear, zombie duck, and zombunny selected, I'll go down to the asset labels and tag them. At the moment, this window is very slim at the bottom because I have multiple assets selected. I'll click on the blue tag in the bottom right and tag them as characters. We can create new tags if we need, for example, enemy. This way, as we've seen previously, I can find models by asset label, by folder, by name, and a mix of those if I need, searchable up here in the project window. I'll take a look in the images as well. What we can see in here is I've got different images I'm going to be using in my user interface. There's some default pieces and also some of the cookies we'll be using to help shape our lighting. What we're seeing here then is I've got a dog and a sheep image, and these will become part of the user interface. There's our heart, which will show up as well, and then sunlight cookie, and two options in it. What I'll do again is to make some folders in here. For example, right-clicking and choosing Create and making a folder called Cookies. Then I'll take my two cookies and pull them in. As part of organizing our project, it's important also to adjust the different incoming texture properties. handling import concerns before they're really a problem. In addition to sorting the cookies into a cookies folder, we might sort the different texture sheets that are part of our particles into different folders as well. I've got a slime ball 4x4, and this is a texture sheet that will become part of an animated particle later on. It's good to organize these into their own folder, maybe effects or attacks in images so we can find them cleanly. I've got my target reticles and my spark, again I'll use in the particles. Textures are images as well, although textures typically get used as part of a material, and so we tend to categorize them differently, as different from images, which may be part of a user interface or a particle. Again, it's a good idea to organize these textures. What we can see here in the textures is that they are named for where they go, plus the nice name. For example, our arches diffuse texture is the diffuse lighting on the arches. That is the albedo plus lighting data. We've got our arches normals and arches occlusion. There's bat diffuse, bat normals, and so on. In here then, we've got our different character textures, such as the clown and the dog, and normals to go with it. As a reminder, a diffuse texture is an albedo, the raw color of that material with no lighting data, plus lighting data. We can see in here we have some extra shadow in the bottom of the clown. A normal then defines for us where there is more surface detail apparently on a model, where the models light as if they had finer detail, in this case the stitching on the clown and buttons and hands. Feel free to organize your project as you see fit, making folders and pulling items in, so that you can get to all of your different assets here in your Zombie Toys project quickly and easily. And when it's time to implement those, you know exactly where to go. Every different asset here in the Unity editor that we'll import has different import settings. And in this video, I'll take a look at importing and adjusting texture import properties correctly. I'll take a look at the arches diffuse. This again is the albedo plus lighting of a material, albedo being the unlit raw color of a material. What we can see here with our arches is that they're laid out in their UV space with some bold colors, as we'd expect on carved wooden blocks, for example. These are marked as a texture, meaning that they're set to be used as a normal image in a diffuse or other map. Under our settings then, under texture, we can see we have normal, editor, graphical user interface and legacy, GUI, sprite or 2D and UI, cursors, cube maps, cookies, light map, and advanced. I'm going to leave this one as a texture because that's the correct texture type for it. In our textures, we have options over how to handle the alpha channel, or are we creating one? Do we have a wrap and a filter mode chosen, and what is the aniso level? We also have options in here for the default sizes and overrides for different platforms. This doesn't need an alpha channel, as these blocks are unwrapped cleanly into this space and will lay onto those blocked out color areas. If we need to generate an alpha for transparency, we can do so by checking alpha from grayscale. We can define this alpha as transparency if we need. The blocks don't have any transparency, so I'll uncheck that. The wrap mode determines what happens to that texture. Does it repeat, tiling along a surface if we've designed it to be tileable? Or is it clamped, only showing on an object once? Our filter mode then determines how that texture blurs over distance. I'm going to leave it at bilinear at the moment. Further exploration of this can be found in the Unity documentation, but is a bit outside of the scope of this course. One of the biggest balancing acts in game production then is the size, the resolution of textures against the available memory for a platform. Typically what we want to do is to author large, uncompressed textures and then let Unity down-res them, scaling them down to a designated maximum size in a certain format optimized for a platform. Right now what we can see here in the inspector is that this arches diffuse comes in at 1024 by 1024 pixels, and it's an sRGB image. It's RGB compressed using the DXT1 compression and takes 0.7 megabytes. We can change this in here altering the maximum size to let Unity compress further. Taking it down to 512, for example, and clicking Apply reduces the size even further, and we can see how it's going to look. Again, we've got a 512 by 512 image, and it takes up 170.7 kilobytes, a significant reduction. However, there may be some quality loss depending on the detail that we are compressing down. Typically, we'll author twice as big as we need something to show. That is, if we need something to end up at a 1K or 1024 square texture, we'll author at 2K, assuming there's detail in the object. In our compression then, we have options in here. Is it compressed? Are we in 16 bits, true color, or crunched? Typically for desktop, we'll let Unity simply compress using the compressed option. We'll use true color on our sprites, preserving their quality and their fidelity in the alpha channel. I'll set this back to 2048 and click Apply. We do have defaults available for other platforms. For example, I'll click on the Web Player setting, and we can choose an override in here, saying, if we want, this is going to be authored for a web player, and maybe the maximum size for this texture tops out at 512 square. Here's an override for standalone, and again an override in this case for iPhone and for Android. Depending on the different install options you chose when you installed Unity, you may see some or all of these options, or have others available. It depends on the platform you're authoring to, and which platform you're working on, Mac or PC. I'll go back to my defaults, and in here, I can always hit Revert at any time to go back to the original properties before I started changing them. When we're bringing in normal maps, it's important to mark them as normal maps. These have been changed to normals, although sometimes what we might see is a normal map comes across as a texture. When normal maps come in as textures, they look the same, but they don't behave properly. What that means is that they're not going to simulate the surface detail correctly, and I'll show what that looks like. I've created a sphere, and I'll press F to frame in on that selection. I'll get a new material on it, just as a test. I'll pull that material on, and now I'll get a normal map on, but configured improperly. From textures, I'm going to take my bat normals, for example, and pull it into the normal map. When a normal map is marked as a texture, it shows oddly. We have a very strange shading going on here on this sphere. No matter where we spin around, it's got a weird dark side, an odd spreading brown darkness on it. We need to make sure then that our normal maps, again choosing bat normals, are marked as normal maps so that Unity knows how to handle their red, green, and blue channels correctly to simulate surface detail. Additionally, because this is a red, green, and blue normal map generated externally, for example in Photoshop or perhaps the Quixel suite or something similar, we don't need to create it from Grayscale, so I'll uncheck that. This option is available if you'd like to bring in a grayscale image, a bump map, and have Unity use it as a height map for generating a normal. Because this already has its correct colors, I'll uncheck that and click Apply. Now the shading changes because this texture is marked correctly, and we can see this sphere definitely looks like it's got additional detail on it provided by that normal map. Make sure then that all of your textures are marked correctly. Most textures, again, will be a texture type of texture. Normal maps should be marked as normal map. If they're not, on import, Unity will pull up a window saying that this should be marked as a normal map. Would you like to fix it now? Or alternately, you can come in and fix it later. Things like occlusion maps are textures, and we need to mark things like our cookies as cookies. What I'll do for cookies is to select them and change the texture type over to cookies. Additionally, I'll set the light type for it, although I can always change it if needed. This is going to go on a directional light, so I'll drop down under Spot and choose Directional, and generate the alpha from Grayscale. I'll click Apply, and this is now a cookie ready to shape a light looking like, well, moonlight through a window. We'll cover the other texture types, such as Sprite, 2D, and UI, later when we deal in user interface construction for our Zombie Toys game. For now, though, in preparation for getting our materials ready to go on our objects, we need to make sure that our textures and our normal maps are marked correctly as such, so that we can put them onto materials and have them shade properly. As a final reminder on organization, make sure at every possible opportunity that you label your assets and categorize them in folders, so that you can always find things and search for them quickly and efficiently. I'll take my cookie, tag it as cookie, and now this is labeled as a cookie, so I can always search here in my project window for cookie. And there's both of my cookies recognizable by name and by tag. In this chapter, we looked at organizing our Zombie Toys game project, getting ready to create and assign our materials, and prepare our objects for implementation into our game level. We created folders as part of our project organization, working in the project window, right-clicking, and choosing Create and Folder, creating and naming new folders and pulling assets into them, either by dragging into a folder or on the left side into our project window's hierarchy. We can always access any folder simply by opening up its parent and clicking on that folder here in the hierarchy on the left side. As a reminder, you can always add a folder to a favorite simply by dragging it up into the favorites. And now Textures is a favorite here in the hierarchy on the left side of my project window. Simply by clicking on it, I can jump right to that folder. We looked at possible naming conventions for our files. Nice names, for example, on our textures, with a note at the end of where that texture goes. We looked at names on our models, and also the possibility of more complex naming conventions for larger projects, dealing in alphanumerics where every 2 or 3 letters, for example, stands for a different section, so we can identify that unique asset out of possibly thousands. Finally, we organized our textures, making sure that textures imported properly, setting the texture type to texture for our albedo and diffuse maps, and setting the texture type to normal for our normal maps. We have choices in here over creating a normal from a grayscale, or recognizing the imported red, green, and blue normals. In addition to textures and normals, we looked at our cookies, selecting a cookie and changing its texture type to cookie, for example, in this case to go on a directional light. We'll cover these again in the lighting sections, but you can always go in and organize your textures beforehand if needed. Remember, in a project you can never be too organized. There's always an opportunity to provide another way to sort, find, classify, and categorize the different incoming assets on a project. I've used my different asset labels here, creating one called Cookie, and assigning it to this cookie, so that up here in my search field in my project window, I can search by label and find that cookie, and then even by name. We want to provide as many ways to find objects quickly as possible, and that involves putting them in folders, organizing them by names, tagging them with asset labels, and being able to search for them quickly and efficiently. In the next chapter, we'll look at some best practices for modeling, rigging, and importing assets into the Unity editor, including animated characters. Then we'll dive into materials here in our Unity editor, exploring the standard shader and all of its different properties, creating materials for our Zombie Toys game, and assigning them to our different objects.